Hi friends, welcome back to AWS with Jaymit. Have you ever wondered what actually happened behind the scenes when you click buy now on Amazon e-commerce website or application? Within just a few seconds, your payment is processed. Inventory is updated, the warehouse receive your orders and shipping partner is notified and you instantly receive a confirmation email. All of this happen while millions of other customers are shopping at the same time. So how does Amazon make this all thing possible? The answer is architecture patterns. In today's video, I will explain the top 10 AWS architecture patterns using one simple Amazon shopping journey. Keep up the watching till end of the video so you will get a better understanding of different architecture patterns which will help you to scale the applications like Amazon e-commerce application is doing. Let's get started. So here are the different architecture patterns which we going to cover in this video. The first architecture pattern is layered architecture. So there are all the different architecture pattern used in different ways. So we will follow one customer from opening the amazon.com all the way to receive the order, and we will move through the journey. You will see where the architecture pattern fits and why the company using it together. So let's start with the first architecture pattern is layered architecture pattern. So layered architecture pattern, imagine you are just open Amazon website or Amazon application. The first thing you see is the website, right? So when you open the amazon.com or amazon.in, you will see the website. But behind this simple web page are multiple layers working together. The presentation layer display the website. The business layer handle the searching product and placing order. The data layer store the product, customers, and orders. Separating this responsibility make the application easier to maintain, easier to scale, and easier to test. That's exactly what the layer architecture pattern is all about. So here you see the presentation layer, the web related all the files are hosted in Amazon S3, and then it's a cloud front in front of the S3. So your HTML, CSS, JavaScript, and all those stuff stored in the S3, and cloud front on top of it that will run your front end. Business logic side, there is a Lambda function, an API gateway, the serverless compute, and database side, Amazon RDS or a DynamoDB. But here the main architecture pattern understand is simply all the layers are separate presentation, business, and data layer. So it is easy to maintain your application best for small to medium web apps, and this way you are able to use your layered architectures like presentation, three-tier architecture we say, right? This is a common architecture pattern in e-commerce or any web applications. Second one is most popular nowadays, microservice architecture pattern. Now you have found your product and click buy now on Amazon. When you open amazon.com or amazon.in, now you found your product and click the buy now. Does one massive application handle everything? Not at all. Amazon split the system into independent services. There is an product services, order services, payment services, and inventory services, and many more services as well. Each time, each team can build, deploy, and scale its own services independently. So that is what the benefit of microservice architecture. If the recommendation service has an issue, customer can still place a order. That's the power of microservice. So splitting application by business capability, independent deployment and scaling of different services. Post, there is a fault isolation. If one service down, it will not impact the other services. So here you see this microservice architecture pattern where user calling user calling the from backend. The request will go to the API gateway, and then API gateway will call the different microservices, Lambda functions or other services, and then database side other stuff, right? So this microservice architecture pattern is break out application into small independent service that can we developed and scaled separately. So large platform can handle this kind of stuff. You are able to divide your application as well. So this is the microservice architecture pattern. Another one is serverless architecture pattern. Now suppose you upload a product review with a photo. Does Amazon keep a server waiting just in case someone upload an image? No. A Lambda function runs only when upload happens. It resize the image, check it, and store the metadata, then stop. No idle servers, automatically scaling, and you only pay when you use the function executes. That's the serverless architecture. So this serverless architecture pattern is like you don't need to keep running your servers 24/7. So whenever something happen, whenever some operation you have to do, it will run your code and do your operation, so you don't have to worry about your uh, managing the servers and other stuff. So run code without managing servers like AWS Lambda. AWS handles scaling, availability, and maintenance of your applications. So this is the way, like when you are building a backend APIs, you can use API gateway, Lambda function. Your Lambda function can do simple operation in Node.js or a Python, and it will do operation on DynamoDB. So this way you are able to build a scalable backend APIs by using API gateway and Lambda function. Lambda function is a serverless compute service. API gateway is a API service. Um, so key point here is you don't need to worry about no server management. Pay only for what you execute, automatically scaling. So this way you are able to build a scalable APIs by using this serverless architecture pattern. Another thing very well to understand is event driven architecture patterns. So now your order has been placed successfully on Amazon. Should the order service directly call every other services? No, instead it publishes an event. So event is kind of like payload, JSON payload, which will be stored into another service. In event-driven architecture pattern, everything. So event is kind of like payload JSON, and that payload JSON will be get passed across different services. So whenever order placed, other services simply react. So inventory updated, say for example, whenever order place, we see like inventory get updated, shipping begins, analytic records the cash, emails get sent out. Because services communicate using event, they remain loosely coupled and easy to scale. So here, say for example, whenever order placed, those orders event will be stored into Amazon event bridge. Amazon event bridge is a event routing service, a serverless event routing service. So whenever order placed, that event goes to Amazon event bridge, and according to the rule set defined in Amazon rule event bridge, it will call different other services. Say for example, payment services, inventory services, shipping services, for email notification services, analytics services. These all different services are running parallelly when some order is placed. So this way, like order event are received to Amazon event bridge, that will route that event to other services. So they will also receive the input event. Event is kind of like JSON payload. Okay, so this way, like some operation happen, it will real time order processing, notification, analytics, and other stuff happening. So services communicate through event, and those are decoupled between producer and consumer. So key point here are service communicate through event, loosely coupled, ideas for asynchronous workflows. So this is the one of the best pattern where you are able to scale your application well in microservice architecture pattern. Another is queue based load leveling. So in this case, now imagine there are some Black Friday sales are running on Amazon. Millions of customers are placing order at nearly the same time. If every request were processed immediately, the system could become overloaded, right? Instead, incoming requests are placed into queue. So here where the queue mechanism will introduce, when there are very heavy kind of traffic coming, we need to decouple the operations. So instead of incoming requests are placed into processing instantly, it will be placed into queue. Worker process them one by one at a manageable rate. Customer experience a reliable services even during the massive traffic spike. So this queue-based architecture will label the load level. So a queue-based architecture pattern when customer doing order operations, if those order operations are stored into Amazon SQS. SQS is a queue services. So once those data are stored into SQS services, those are will be processed by Lambda functions. So there is a worker fleet, right, that will process this queue and then store those processing result into database. So whenever heavy load happening, we are able to decouple operations performance by using this kind of queue-based load leveling architecture. So bulk order processing happen through the background job as well. So whenever the very high traffic spike, to improve a reliability background processing, we are able to use this kind of queue-based load leveling architecture pattern. So this is the one of the good architecture pattern we'll used in heavy loading traffic kind of situation. Sometimes we also use a streaming architecture, MSK, and other stuff like kinesis to store the events. Another one is a fan out architecture pattern. Here, so fan out architecture pattern. Say for example, one order should trigger many independent actions. In this fan out architecture pattern, whenever order placed, it will do multiple other actions. Send an email, update inventory, generate an invoice, notify the warehouse, update the analytics, right? Instead of doing all this, that in one service, Amazon publish one event and multiple consumer process it in parallel. That's the fan out pattern. So one event, many independent consumers. So whenever order placed, this Amazon SNS service is simple notification services. So whenever we place a event into SNS topic, the SNS service simple notification service will have a topic. When we push order event into that topic, this topic have a multiple subscriber. Say for example, other subscriber Lambda functions and other subscriber. Those subscriber, what all the subscribers subscribe to that topic, they all receive that event, right? So this is a fan out pattern. A single message is published to multiple subscriber. So notification update to multiple system. One event trigger many consumer. Parallel processing happen, notification and analytic kind of system, right? So this is also one of the very popular fan out pattern in AWS architecture patterns. Now another is a course architecture patterns. Think about how many people browsing product compared to how many actually buy them. Millions are reading product informations. Only a small percentage are writing new orders. Amazon separate read operation from um, write operation. So read model are optimized for speed, while write models are optimized for consistency write operations. This improve both performance and scalability. That's where the course architecture are there. Separate read and write operation for better performance and scalability. So whenever anyone search the do the search query for product, it will only read from reader instance or read replicas. And when someone do order placing and we want to do write operation, there is a different write replica for it. It will do operation into this. So high read write workload are different. Separate read and write model optimize the performance useful for heavy read workloads. So this way, this course architecture pattern are used. Here, another very popular architecture pattern in AWS is circuit breaker architecture pattern. This is also one of the very popular architecture pattern. Now imagine the payment provider suddenly goes offline. When you place an order and imagine now payment provider suddenly goes offline without protection, the application keep trying to contact it over and over, right? everything slow down. Instead, the circuit breaker temporarily stops sending the request. Customer receive a friendly message instead of waiting forever. Once the payment service recover, traffic resume automatically. This prevents small failure from becoming a much bigger problems, right? So in this circuit breaker architecture pattern, whenever applications like order placed, it will don't wait for the payment operations. It will try sometime, and if still failing, it will the fallback, it will have a fallback response, right? So circuit breaker architecture pattern will do that fallback from failed services. When we doing external operation, external services or a payment gateway, this will be the best architecture pattern to be used. Stop repeated failed requests, prevent cascading failures, provide a fallback response common with external APIs. So prevents cascading failing by stopping requests to failing services. So this is one of the good architecture pattern will be used when you are doing some external operation. Another is a bulkhead architecture pattern. So suppose Amazon's recommendation services become overloaded. Should checkout also stop working? Definitely not, right? Each critical service has dedicated resources. So in this bulkhead architecture patterns, each dedicated service will have a dedicated different resources. If one service fail, the other continue operating normally. It's extract like a ship with watertight compartment, right? So one compartment floods, the ship keep floating. That's the bulkhead pattern. So say for example, here all product services, order services, payment services are totally isolated in terms of compute and storage. So isolate failures by providing a resource so that one failure service don't affect the other services. This is a bulkhead pattern. Isolate failures, dedicated resource per services, improve the resilience per service queues and databases. So this will be a good pattern for fail tolerance and scalability. The last one, Strangler Fig. So this is also one of the good architecture pattern when we are migrating a legacy system into modern architecture. Uh, so say for example, Amazon was not built in a single day, right? Large company often have a legacy system. Replacing everything at a once is a risky. Instead, they gradually replace one module at a time. Today, they modernize authentication. Next day, they modernize payments. Then inventory. Eventually, the old system disappear completely. That's the Strangler Fig pattern. It's one of the safest way to modernize your enterprise application. So whenever you want to migrate your bigger legacy system, so you did not modernize everything in one go. You will do one service by service by, say for example, first you try with product microservices, then card microservices, order microservices, payment microservices, and then side by you keep running your monolithic application as well. Gradually replace part of your monolithic application with new microservice. Modern legacy app gradually replace one module at a time. Low migration risk, great for monolithic to microservice migration. So these are the top 10 architecture patterns. So now we see at Hall together. Let's quickly recap this our Amazon journey. We started with layered architecture to we started with layer architecture. This one uh, to build the applications. We used microservices to separate the business capability. Then we use serverless handled event based execution. Then we have event driven architecture connected different microservices. We have queue based services to handle the decoupled high traffic in flash, then Black Friday like scenarios. These are the fan out trigger multiple workflows together. Course to optimize read and write operation. in heavy load. Circuit breaker handles the different failures with third party. Bulkhead isolate the failures, and Strangler Fig help modernize legacy system. So together, this pattern help company build cloud application that are scalable, reliable, and resistant. If you found this video helpful, please like the video and subscribe to AWS with Jaymit. So if you want to learn more about AWS, I have a lot of other videos in my channel. Please go ahead and explore it. Don't forget to subscribe. Thank you for watching.